Hey everyone, I'm Bhumika. Today we are going to discuss class 9 chapter 1 motion from physics. This is the second part of this video. In this video we will discuss distance and displacement, difference between distance and displacement. Distance is a scalar quantity. Displacement is a vector quantity. Distance traveled by a moving body cannot be zero. Final displacement of moving body can be zero. Scalar Scalar quantity is a physical quantity which has magnitude only, not direction. Examples are length, mass, time, speed, energy, etc. Vector. Vector quantity is a physical quantity which has both magnitude as well as direction. Examples: displacement, velocity, acceleration, moment, force, etc. Physical quantity. Physical quantity is a quantity which can be measured and expressed in magnitude, value, with or without unit. Example: length can be measured and expressed as 5 meters. Relative density can be measured and expressed as 0.8. Speed. Speed is defined as the time rate of change of distance of any body. Or we can say the distance traveled by a body per unit time is called speed. Here is the formula of speed: distance traveled by total time taken. If a body travels distance s in time t, then its speed v is given by v is equals s by t. These are some extra points of speeds you can write down in your notebook. Speed is a scalar quantity. Speed is neither positive or zero but never negative. Speed of a running car is measured by speedometer. Speed is measured in centimeters second in CGS system of units. Meter per second in SI units. Kilometer per hour in practical life when distance and time involved are large. Uniform speed. If a body travels equal distance in equal interval of time, no matter how small these time intervals may be, is called uniform speed. We can take an example. A car is moving with equal distance in equal interval of time. Uniform motion. It's as it is as a uniform speed. If a body travels equal distance in equal interval of time, it's called uniform motion. Variable speed. A body is said to be moving with variable speed if it covers unequal distance in equal interval of time, however small these interval time may be. Uniform motion. Non-uniform motion. A body has non-uniform motion if it travels unequal distance in equal interval of time. We can take an example. A car is moving so fast, then it slows down. Average speed. Average speed of a body is the ratio of total distance traveled to the total time taken to cover this distance. Here is the formula of average speed. Total distance traveled by total time taken. We can write it as like this. Example: let a car covers first 25 km in 1 hour, next 35 km in half hour and last 30 km in 1 hour. Then the average speed is 25 plus 35 plus 30 by 1 hour plus half hour plus 1 is equals 36 km per hour. Instantaneous speed. When a body is moving with variable speed, the speed of the body at any instant of time is called instantaneous speed. Velocity. Velocity is defined as the time rate of change of displacement of a body, or we can say the distance traveled by a body in unit time in a given direction is called velocity. Here is the formula of velocity: displacement by the total time taken. If a body travels distance s in time t in given direction, then its speed is v is given by v is equals s by t. These are some extra points for the velocity. Please write them in your notebook. Velocity is a vector quantity. Direction of velocity is the same as the direction of displacement of the body. Velocity can neither positive, zero or negative. Velocity can be changed in two ways. These are the important points. Please write them in your notebook. By changing the speed of our body, or we can change by keeping the speed constant but the changing the direction. Velocity is measured in centimeters, centimeter per second, meter per second, kilometer per hour. Uniform velocity. If a body travels specified direction in straight line and moves over equal distance in equal interval of time is called uniform velocity. No effort or force is required to move the body with uniformly velocity. Variable velocity. If a body is said to be moving with variable velocity if its speed or its direction or both changes with time. Average velocity. When a body moves with variable velocity, the average velocity of the body is the ratio of the total displacement covered by it to the total time taken by the body. Here's the formula of average velocity. Initial velocity plus final velocity by 2. Or we can write it as u plus v by 2. Instantaneous velocity. When a body is moving with variable velocity, the velocity of the body at any instant is called instantaneous velocity. Difference between speed and velocity. It's so necessary. Please write it at important question. Speed, velocity. Speed is the time rate of change of distance of a body. Velocity is the time rate of change of displacement of a body. Speed tells nothing about the direction of the body. Now velocity tells the direction of motion of the body. Speed is a scalar quantity. Velocity is a vector quantity. Speed of a body can be 0 or positive but never negative. Velocity can be 0, negative, positive. Average speed of moving body can never be 0. Average velocity of a moving body can be 0. Acceleration. Acceleration is defined as the time rate of change of its velocity with time. Here is the formula of acceleration. Change in velocity by total time taken. Or we can say final velocity minus initial velocity by time taken. Suppose a body moving with initial velocity u changes to the final velocity v in time t, then a is equals v minus u by t. Here are some extra notes or extra points of the acceleration. Acceleration is a vector quantity. Direction of acceleration is the same as the direction of velocity of a body. Acceleration can be neither positive, 0 or negative. Acceleration of a body is 0 when it moves with uniform velocity. Acceleration is measured in centimeters per second square, meter per second square, kilometer per hour square. Uniform acceleration. A body is said to be moving with uniform acceleration if it travels in a straight line and its velocity increases by equal amount in equal interval of time. Or we can say a body has uniform acceleration if its velocity changes at uniform rate. Example: the motion of a freely falling body is uniformly accelerated motion. Here we can take an example. A ball slant from the motion of a sliding block on a smooth inclined plane is uniformly accelerated motion. We can take another example. Non-uniform acceleration. A body is said to be moving with non-uniform acceleration if its velocity increases by unequal amount in equal interval of time. Or we can say a body has non-uniform acceleration if its velocity changes at non-uniform rate. Example: the motion of a car on a crowded city road. Its speed velocity changes continuously. We can take an example. A car is moving so fast, then it slows down, and then again it's move. Retardation or declaration of negative acceleration. A body is said to be retarded if its velocity decreases with time. We can take an example. A car is moving so fast, then it slows down. A car is declaring to come to a halt. Graphical representation of motion. Uniform motion. Distance time graph. Uniform speed. Here is a graph. When a straight line is going, it means it is uniform motion. The slope of distance time graph indicates speed. Speed is equals AB by OB. Speed time graph uniform speed. When a body is parallel lines, when body is at rest, it shows two parallel lines. Area of the speed time graph indicates distance traveled. The area of A, B, C, D gives the distance traveled between time 1, time 2 and seconds. Non-uniform motion. Distance time graph uniform accelerated. When it shows any curved line, it means non-uniform speed. Distance time graph uniform retardation. When any graph shows curved line, now it was not showing any straight line, sloping line, inclined line, it means it is non-uniform. Speed or motion. Speed, velocity, time graph, uniform accelerated. Here is a straight line, it means it is uniform motion. The slope of velocity time graph indicates acceleration. Acceleration is equals AB by OB. The area of OB gives the distance traveled by a body. Speed, velocity, time graph, uniform retardation. Here a body is showing the slope of the velocity time graph indicates retardation. Retardation is equals AO by OB. The area of the OAB indicates the retarded line. Speed, velocity, time graph, uniform acceleration. When the initial speed is not zero, the slope of the velocity time graph indicates acceleration. Acceleration is equals AB by OB. The area of OCAB gives the distance traveled by a body. Equations of uniformly accelerated motion we will discuss in the next class. So thank you. This is all for the today.